Hey, this is Ken Rosever, and we're going to look at graphing exponential functions. I went over some of these in class, but in case that conversation went too quickly for you, here is an opportunity to review that. An exponential function is a function of the form f of x equals or y equals a to the x, where a is the base, and that base, a, has to be a positive value not equal to 0. And the reason for that is we want the function to be continuous. As long as a is bigger than 0, then a to any n will also be bigger than 0, where n is a real number. So if the base were 2, 2 to any value n would come out positive, is positive. However, if your base is not a positive, if your base were negative, then 2 to the third would be negative, negative 2 to the third would be negative, but negative 2 squared would be positive, and so your graph would not be continuous. It would be jumping back and forths to different quadrants, quadrant 1 down to quadrant 4, quadrant 1 down to quadrant 4, or when you're on the negative side of things, it would be jumping from quadrant 2 to quadrant 3 and back and forth. So for reasons of continuity, we say that the base must always be bigger than 0. Oh, and it cannot equal 1, because if it equaled 1, we wouldn't have exponential growth or decay. We would just have a flat line, because 1 to any power is 1. Okay, so when these conditions are met, you have a one-to-one continuous function. And I'll give you an example. So let's say you have y equals 2 to the x. This is an exponential function. And how do we graph it? Well, it's actually pretty easy, because we know that 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the negative 1 is a half, 2 to the negative 2 is a quarter, and so we get this graph here. And because our a, our base, when a, that's a when a is bigger than 1, we get exponential growth. Probably the two most important points on here to remember are 0, 1, and 1, the base. The base in this case is 2. And the other important thing is, notice that for larger negatives, you keep getting more negative. 2 to the negative 8 is 1 over 256. 1 over 256 is still positive. It's getting closer to 0, but it doesn't reach 0. There is no power x that is so negative that you can make a positive equal 0. It does get closer and closer to 0, but it never crosses that line. It never hits that line, because a power of a positive base will always be a positive number. That's what I was saying over here. If the base is positive, then any power of the base will also be positive, which means you can't cross this line, which means this line is an asymptote. Okay? It is a line that the graph approaches but does not cross. This asymptote is the x-axis. Its equation is y equals 0. Let's do another one. Let's say you had y equals 3 to the x. Well, that one's easy too, because it's going to do the same thing. It's going to approach 0. It's not going to hit it. It's going to go through 0, 1, because 3 to the 0 is 1. And instead of going through 1, 2, it's going to go through 1, 3, because 3 to the 1 is 3. So you'll get a graph that looks like this, asymptote in the same place at y equals 0. So those are pretty easy. Well, what if I had a base that was like a fraction, a positive fraction, because the bases have to be positive. Let's say you had y equals 1/2 raised to the x power. Well, that's not that hard either. 1/2 to the 0 is still 1. 1/2 to the 1 is a half. 1/2 to the negative 1 is 2. And you can keep going. 1/2 squared is a quarter. 1/2 to the negative 2 is 4. And you'll get this. It will still approach 0, but will not cross 0. So you have the asymptote in the same place, and you still have that point 0, 1, and this point, which is 1, the base. You'll also notice that this graph is the reflection of this graph here. All these points, the 1/2 or the 1, 2 is now negative 1, 2 on this one. And that is because 1/2 and 2 have the relationship that 1/2 is 2 to the negative 1, right? So if I have 2 to the negative 1 to the x, I have 2 to the negative x. And you guys should know that when you put a negative inside the function, it flips it across the y-axis. It reflects it from this direction to this direction, right? All right. So that was to be expected. Let's do a couple more. If I asked you to do y equals 1/4 to the x, well, that's not hard. It goes through the point 0, 1, 1, a quarter. Maybe that's a quarter. Or because, it's a fraction, it might be easier to do the negative 1. So at negative 1, 1/4 to the negative 1 is 4. 1, 2, 3, 4. And there you go. There is your exponential function base 1/4. Which, of course, would be the reflection of your exponential function with a base of 4. Okay. That would look like this instead. So hopefully you get the idea. They're very easy to draw. What messes people up sometimes are questions about the domain and range and transformation. So let's go through each and talk about the domain. Since you can take the power of any positive base, you can take any power of any positive base. There is no restriction. You could do 2 to the pi with your calculator. Your calculator somehow interpolates that and figures out what that would equal. 2 to the 1/2 is the square root of 2. So you know that fractional and decimal powers are possible. So the domain is unrestricted for an exponential function. It's negative infinity to infinity. The range, if it hasn't been shifted, will be 0 to infinity, because you can't have a positive, a power of a positive coming out to a negative or coming out to nothing, to 0. So all of these, the domains are infinity to infinity, and the range is 0 to infinity for all of these. All right, let's do some transformations, and then we'll call it quits on this. So some transformations. Let's say you had y equals 2 to the x minus 2 power plus 3, and you wanted to graph that and find its domain and range. The easiest way to do that is actually to draw the basic y equals 2 to the x function, and then follow my instructions after that. Let me just draw that first. You'd hit 0, 1, you'd hit 1, 2, 2, 4, negative 1, half, and so you'd have a graph that looks like this. That is your basic y equals 2 to the x graph. Let me zoom in a little bit on this, and you can see it better. All right, so what am I going to do with that? Well, I don't feel like drawing these points again. So I'm going to do something I haven't done with you guys maybe before. And instead of translating the graph, I'm going to translate the axes. Right? One way to shift a graph is to shift every point. Alternative to that is to shift the axes under the graph, as in shift all the reference points. I use an example like in class, or at home, let's say your dog won't come to you. What do? You come to the dog. And both accomplish the same task. Well, let's say I don't feel like moving the graph. I don't feel like redrawing this graph. And that's because this can be a pain for some people. So what can I do instead? Well, I can redraw the axes, because those are the only points of reference on here. So this wants to move 2 to the right. Well, rather than move the graph 2 to the right, I'll shift the axes to the left. This is my new y-axis. This wants me to move all the points up 3. I don't feel like it. So rather than move the points up 3, I'm going to move the axes down 3. This is my new x-axis. And that means this right here is the asymptote. It's no longer at y equals 0. It is now at y equals 3. It's pretty cool. So this is the lazy person's way to graph these. Rather than redraw the graph, just shift the axes. Draw the basic graph, shift the axes. The domain now would still be unrestricted, but the range, because now the lowest it can go is just shy of 3, would be 3, not including 3, to infinity. Let me do another one with you guys. Sorry, I was out of view there. All right, let me do another one of these. So domain, negative infinity to infinity, range, not including 3, but from there up, not including 3. All right. So let me do one over here. Let's say I wanted to graph y equals 1/3 of x, or 1/3 to the x plus 2 minus 4. Well, what am I going to graph? Oh man, I meant to do this lightly. Let me do it in pencil. So the basic 1/3 graph is going to be 0, 1, 1, 3rd, negative 1, 3. And it's going to look like so. Whoa. Nope, that didn't last long. And there it goes, right? I'm not going to redraw that. This tells me to shift all the points 2 to the left. Well, I'm not going to do that either. I'm going to shift the axes, the y-axis, 2 to the right. This tells me to shift all the points down 4. Rather than do that, I'm going to shift my x-axis 1, 2, 3, 4 up 4. So now this is my x-axis, that's my y-axis. This actually here is the line x equals negative 2. This here would be the asymptote at y equals negative 4. Asymptote graph. And there's other approaches to doing this, but there you go. That's one very nice way of doing it. Let me do one last, or two more. Do a little time check here. I'll do 2 more on a separate video. All right.